What's up, Algebra 2? This is a full polynomial test review for anybody that missed today. If you want to check out this as a quick review, and even though you're here, you can, but if you're in class, it's not going to be anything new. Names for polynomials based on degree and number of terms will definitely be on the test. You'll need to understand like x squared is quadratic, x to the third is cubic, x to the fourth is quartic. I didn't put it on there, but x to the fifth is quintic. Also monomial is one term, binomial like this one right here is two terms, or three terms if it's a trinomial. You'll need to be able to sketch a graph without a calculator, even in standard form or factored form. You'll need all of this. You'll have to be able to find real roots, graphing, and then setting them equal to 0 using synthetic division. We'll see some of that in a minute. Something that'll definitely be on the test is straight up imaginary roots always come in conjugate pairs. That means that if you see 2 plus 3i, 2 minus 3i is a factor, or if you see 4i, that's imaginary, well, negative 4i is also a factor. They always come in what's called conjugate pairs. Conjugate meaning one's positive and one's negative, but it's the same. Even powers bounce at their zeros, and factors with odd powers go through. That's part of being able to sketch a graph in factored form. Being able to write an equation given roots. So for example 2, well, x minus 2 is the factor for that because 2 minus 2 is 0. If negative 3 is a 0, x plus 3 would be a factor. And if 5i is a factor, again, they come in conjugate pairs. That's what we were just talking about a second ago. If you were to set that equal to x and go backwards in the process, x squared plus 25 is how you would get 5i as a factor. If you set that equal to 0, subtract 25 to the other side, and square rooting in negative 25 would create plus or minus 5i. If you see the word regression, you'll need to go through the stat edit process where you're creating an equation in your calculator. We've talked a lot about in behavior. What I've got right here is in every possible answer. What's in the blank is what changes. It's either infinity or negative infinity, depending on if it's going up or down on the ends. And then the last thing, using synthetic division, use the 0 of the divider, or remainder of 0 means it's a perfect factor. And you'll have a question where it says, is this a perfect factor? And you'll have to, use the 0 and use synthetic division. So pause the video if you need to get these answers down. But basically I'm combining like terms with subtraction in the first one, and I am distributing in the second one. When you multiply coefficients, they really multiply, but when you multiply x's, their power increases. The one on the left is a cubic polynomial because it has 4 terms, and it's power to the third. That's what makes it cubic. And then this one is a quintic because of x to the fifth, and it's a trinomial because there are 3 individual factors. Number 3, we've got for the polynomial, each one needs to be named by degree and number of terms. Sketch the graph and write the end behavior. So this right here on the left is a quartic trinomial. It's a power of 4. It has 3 terms. Because it's a negative, it goes down, down. And that's what this part right here is saying, negative infinity for both ends. And for the other one, this is a negative odd, so it's going up to down. So that's why this is positive and this one's negative. And this is a cubic binomial. Power of 3, 2 terms. Find the following information. So each of these I'm set equal to 0 and solved. So 1 minus 1 is 0, 3 minus 3 is 0, negative 2 plus 2 is 0. To answer the multiplicity part, I'm looking at the power that's outside of the parentheses. So the one that had a 1, 0 has 2 multiplicity. So does negative 2, but the one in the middle has a power of 1 since there's nothing written. So we can look at this and add up the multiplicity to understand it's a quintic. It should be bouncing on the ones that are even. So I put 1, 3, and negative 2 all on the number line here, and then we sketched the quintic graph, but it bounces off of the ones that had a multiplicity of 2. It goes through at 3. So same thing here, it's another quintic because you have 1, 3, and 1 as the powers, and all together they're multiplying to give you a negative odd that's to the fifth. And so we again looked at all the zeros, figured out where they cross, and honestly all of these are crossing because they're all odd multiplicities. And so we go through -3, goes through 1, and goes back through, goes through 0 and back through 1. Number 6, we talked about how this one has to be set equal to 0, and we get 2x minus 3 equals 0. Solve and you get 3/2, which is the same as 1.5. So that's where you see it crossing here, or bouncing here. It has a multiplicity of 2. It's crossing at 5, and this is a cubic. And then we talked about how if you want the y-intercept, you need to go through the process of multiplying them all together. But really, you're just trying to see what the constants do. So -3 times -3 is 9. You then multiply that against the next one, and that gives you -45. So we know that that's going to cross at -45 on the y-axis. How many total zeros does each function have? This part right here we took out because it's more honors, even though I explained it in class. The highest power tells you how many total zeros there are. Some are real, some are imaginary. This one actually has 6 imaginary solutions, and the one on the right has 3 zeros total. So 6 total zeros, 3 total zeros, all based on the highest power. So factoring, we did a little bit of an extra push this chapter talking about cubics. So you have to kind of memorize this form, AB, a squared, AB, B squared, and then SOAP stands for same, opposite, always, positive. So if you've been in class, that's something that hopefully you remember us talking about. So we have figured out the cube root of 8 is 2, the cube root of 125 is 5, and then we put it in the form. Same thing with B, 27, the cube root of that is 3, 1, the cube root is 1, we put it in the form. And the last one, C, it's a cubic, but we have to take out a 2 first, and then what's left can be done using the form and SOAP. The last two are a review from 2 chapters ago. This is called a quadratic form of factoring. It still has to multiply to be 8 and add to be -6. That is -4 and -2. But this one in the front is considered a difference in perfect squares. What multiplies to be -4 but adds to be 0 is 2 and -2. So E is actually that same thing twice. Difference in perfect squares, 16 is a perfect square, -4 and +4. But then just like this one over here, this can turn into x plus 2 and x minus 2. Check out the homework video for this one. I explained this one earlier in the other video that I did. So when we're talking about understanding if something has a perfect remainder of 0, we can use synthetic division. Just make sure that you use the 0 of the given factor. So let's drop, multiply, 1 times -2 is -2. Let's add that together. These now multiply to give you 10. These add together to give you 3. -2 times 3 is -6. These add together to be -4. -2 times -4 is +8, and those add to be 0. So the answer is yes, because you got a remainder of 0. X plus 2 is in fact a factor. Synthetic division here. I talked about this one in the homework video, so flip over to the other video. Find all the zeros of this one. So what we're looking at here is starting out looking at the graph. So we started off eyeballing the graph, and it crossed at 3. Sorry, it bounced at 3. It also hit at 5, and it also hit at -1. So in class, I demonstrated the graphing calculator, and so we were able to kind of spy out this x to the 4th idea. It came through -1, it bounced at -3, and then went back up through 5. And then I was able to demonstrate how we can turn that into factored form, thinking backwards. X plus 1 goes with -1. Since it bounced, we know it must have been x minus 3 squared, and then it went through at 5, so it's also x minus 5. We started graphing this one, and when we graphed this one, it crossed at -2. It crossed at -2 in the picture. So I took that -2 and used synthetic division. Once I got to the end and I saw that it was a perfect division, I turned everything back into a polynomial. Subtract 25 to the other side, and so to find all the zeros, including the imaginaries, I square rooted negative 25 to get 5, or negative 5. So negative 2, and then plus or minus 5i there. Talked about 14 in the other video. In number 16, we talked about how the y-intercept is always the back number, so that one is 4. When we graphed it, it didn't cross the x-axis at all, so it has no x-intercepts. We used a special feature in the graphing calculator. Whenever you're graphing things, this is probably a bad example because I don't have anything that is turning around. So for something like this, if I want to find the bottom of that second trace, choose number 3 for minimum, and then go left of where you think it's crossing, hit enter. I said crossing, it's more about the bottom of the curve. Go right of that and press enter, and then it'll zoom right in on where it went at the lowest. Now watch out for this right here. This is an approximation. This is scientific notation, so really they hit at 0, 0, 0. So we can also do that with relative max and relative minimum. In behavior, since this one's facing up in both cases, we did as x goes to negative infinity, f of x goes to positive infinity, and then as x goes to positive infinity, f of x goes to positive infinity. That basically just means it's going up on both sides. Cubic regression, whenever you see cubic regression, that's the idea of stat edit. When you hit stat and go to edit, you put in all the values here in the calculator. You go to stat, go right, and now we're going to hit number 6, cubic regression. And when I calculate it, I hope it spits me out to the main screen. And this is your equation. 1x to the third plus 3x squared minus 1x minus 1. We then used that equation to plug in 3, and it calculated 50. Look for the word regression. That's how you know to do that. Talked about this one in the video right before this. Lastly, we talked about matching equations based on their graph. This is the whole idea of the relationship of factors and bouncing at even multiplicities. So this one right here has a 0 in the front, that when x is 0 it kills the whole thing. So this graph right here is crossing at 0. And then the other two values were negative 2 and positive 2, so we see those hitting here. It's actually bouncing at negative 2, so that's why it bounces right off at negative 2, but then it goes through positive 2, and that's that one. B, another 0 out front, so it's got to go through the origin, but this time it's bouncing off of positive 2, so we see that one there. This has all odd multiplicities, so it crosses at 0, crosses at negative 2, crosses at positive 2, so that's this one. No bouncing off those zeros. And D, because x is squared out front, that means it's really just going to bounce off the origin, because that's where 0 has a multiplicity of 2, and then it's actually crossing at negative 2 and positive 2. So hopefully this is a good review, even if you were here in class today. You know, we got a test tomorrow over all this stuff, and if you weren't in class and you thought I was going too fast, it's because I'm trying to squeeze this video in the allotted time. So please ask questions tomorrow. Come in early and spend some time with me right before the test if you have any questions or you're concerned about anything in particular. Have a good night, and I'll see you tomorrow. Peace.